What if everything you know about the universe is wrong? Have you ever wondered why anything exists at all? When you gaze into the night, beneath a tapestry of endless stars, do you sense the weight of infinity pressing gently on your soul? What is it that calls us to wonder about the origin of all things? This longing to understand has echoed through every heart, across every age, an ancient curiosity woven into the fabric of our being. We ask not just how the universe began, but why there is something rather than nothing. What stirs reality into existence? Such questions arise from the rhythm of our lives. Every sunrise, every heartbeat, every fleeting moment. We see beginnings everywhere. A child's first breath, a story's opening line, a melody's first note, a dawn's first light, each a symbol of origin. So we search for the universe's first moment, hoping to find meaning in the silence before creation. We imagine a cosmic dawn, a single breath when time, space, and possibility unfurled from darkness. In that imagined instant, all that ever was, space, time, matter, and energy, blazed into being. Our stories are shaped by this yearning for beginnings. For countless generations, we spun myths, cosmic eggs, divine words, giants whose dreams became mountains and seas. These tales were our first attempts to touch the infinite. But then, we learned to see with new eyes. We built instruments to peer deeper, to unravel the Milky Way's shimmering river of suns. Our universe grew vast, its scale both terrifying and beautiful. If we could rewind the cosmic story, we'd find everything drawn together, closer, denser, more mysterious. 13.8 billion years ago, all that is was compressed into a single, unknowable point, a singularity. Yet at that edge our understanding falters. The laws we trust dissolve into mystery. The singularity is a horizon, a veil beyond which science cannot yet see. Now some wonder, was the Big Bang a true beginning, or just a transformation in an eternal, unknowable cosmos? For most of human history, our understanding of the cosmos was woven from myth and observation with the naked eye. We saw the sun rise and set, the moon wax and wane, and the stars wheel across the sky in predictable patterns. We created gods to pull the sun across the sky, goddesses to paint the stars onto the night. These explanations were beautiful and poetic. They helped us find meaning, but they placed humanity at the center of everything. The universe was made for us, a cozy human-scale cosmos. Then something remarkable happened. We invented new ways of seeing. The telescope was our first great leap, a lens that shattered our terrestrial perspective. Planets were not just wandering stars. They were worlds with moons of their own. The Milky Way was not a celestial cloud. It was a river of countless distant suns. Our cozy universe suddenly expanded, terrifyingly vast. New ideas arrived, driven not by myth but by mathematics and observation. The language of the universe became physics. This shift gave us the dominant scientific story, the Big Bang. The evidence is powerful and compelling. We observe galaxies rushing away from each other. The universe is expanding. Rewind that expansion, like a film in reverse, and everything was closer together. Go back 13.8 billion years. Everything we can see would be crushed into a hot, dense point, a singularity, and our laws of physics falter there. It is a wall, a point beyond which current science cannot see. So some physicists wonder, was the Big Bang a beginning or a transition? Perhaps it was a transformation in a much older, perhaps eternal cosmos. These are not idle speculations. They're frontiers of modern cosmology, explored with math and observation. They force us to confront ideas that stretch the fabric of our imagination. What if the universe has no beginning? What if it has always been here, in some form or another, and will always be? To grasp a universe without a beginning, we need to wrestle with a concept our minds struggle to contain: infinity. We can talk about it mathematically, we can use a symbol for it, but we can't truly picture it. Try to imagine a road that never ends. You can imagine traveling 1 billion years, 1 trillion years. There is always more road ahead. You never arrive. The same is true for time. An eternal past means there was no first day. For any moment there was always a moment before it. But we can use analogies. Think about the surface of a sphere, a smooth globe. Pick a point and walk in a straight line. You can walk forever and never fall off an edge. The surface is finite in area, but unbounded. No start or end exists on the surface itself. What if space-time, the four-dimensional fabric, has a similar property? What if it curves back on itself and eliminates the need for a starting point or an edge? Let's try another one. Imagine a circle. Where does a circle begin? You can pick any point and call it the start. That's an arbitrary choice you impose. The circle itself has no inherent beginning or end. It's a continuous, unbroken loop. Some cosmological models propose the universe could be cyclical. It might expand from a hot, dense state, continue expanding for trillions of years, until gravity pulls everything back together and collapse into a big crunch. From that crunch, a new Big Bang could erupt, a new universe forming. In this cyclical model, our Big Bang wasn't the beginning, but one chapter in an endless book. Our universe could be the latest in a long, unending chain. Time itself would have no ultimate origin point. It would be a grand cosmic loop. This is one way scientists try to imagine a self-contained cosmos with no creation from nothing, a universe without a beginning, strange but possible. So, how could we ever know? Are these ideas just philosophy or testable science? Scientists hunt for clues. They build instruments to look deeper and further back in time. We launch space telescopes that can peer at the dawn of cosmic time. One of our most powerful tools is the cosmic microwave background, the faint leftover radiation from the Big Bang, a baby picture of our universe when it was only about 380,000 years old. By studying subtle temperature variations, we learn about early conditions. If the universe had a definitive beginning, we'd expect certain patterns in this ancient light. But if the universe is cyclical or has pre-Big Bang history, it might have left ghostly imprints on the CMB. Some scientists are searching for specific signatures, subtle circular patterns or cold spots. For example, a previous cosmic cycle might leave concentric rings in the sky, or cold spots, faint echoes of an earlier cosmos. Finding them would be revolutionary. It would be the first physical evidence that our universe is not the first. Another avenue is quantum mechanics, the physics of the very small. When you try to combine general relativity with quantum mechanics, you enter strange territory. Some quantum gravity theories suggest space-time is granular, made of tiny, indivisible atoms. In those models, you can't squeeze the universe to an infinite point. There's a minimum size. If you rewind the universe, it doesn't hit a singularity. It reaches max density and bounces. Our Big Bang could have been a big bounce from a previously collapsing universe. These ideas are cutting edge. Scientists build massive instruments to test them. We smash particles to recreate early universe energies for a fleeting instant. We peer deeper with telescopes and refine the mathematics to describe unseen realities. Every new discovery, whether it confirms or shatters our ideas, brings us closer to understanding cosmic origins. The questions remain vast, but our toolkit grows more powerful every year. The edges of our knowledge are where the real adventure begins. Thinking about these possibilities, an eternal past, a cyclical cosmos, a universe without a beginning, can be profoundly humbling. It can make you feel unbelievably small. Our lives are less than a blink in the face of cosmic eternity. Our civilization, our planet's entire history, fleeting. Our galaxy is one island of light in an endless ocean of space and time. It's a perspective that can feel overwhelming, a cosmic vertigo. But there is another way to see it, as wonder and excitement. To be part of something so vast, so ancient and so mysterious is a breathtaking privilege. We are not separate from the universe, we are a part of it. The iron in our blood, the calcium in our bones, were forged in the hearts of stars. We are, in the most literal sense, stardust. We are the universe made conscious, capable of looking back at itself. To be a brief, flickering awareness in an eternal cosmos is not a tragedy. It's a miracle. This idea of a timeless universe doesn't provide easy answers. It inspires deeper questions. It frees us from needing a single ultimate origin and invites us to explore the processes shaping an ever-evolving reality. Science is not a destination. It is a method, a continuous journey of discovery. Every discovery reveals how much we don't know, and that is the most exciting part. The edges of our knowledge are where the real adventure begins. So the next time you look up at the night sky, don't just see points of light. See the questions. See the immense history written in that darkness. Wonder if that story has a first page, or if you are simply reading one chapter in a book with no beginning and no end. The cosmos is the greatest mystery we have ever faced, and the quest to understand it is the noblest and most thrilling adventure of the human spirit. Keep looking up, keep asking. The universe is waiting.